Hello everyone, welcome to Quick Tempo Math. Here I am your chemistry guide and ready to give you the short tricks of the chemistry for your MHT CET exam. So let's find our way between the exceptions of the chemistry. Today I will solve your confusion of the finding the work done. So basically there are three formulas we are taking here. So our first formula is W is equals to minus PEXT and delta V, where delta V is equals to change in volume. Delta V can be V2 minus V1, that is final volume minus initial volume, and PEXT means external pressure. You have to remember some keywords or find some keywords in the question to use this formula. These keywords give you the clue that you have to use this formula in your question. So first is external pressure. If you are given external pressure in your question, then the formula for the finding work done or any term in this formula. And second is pressure against or expansion of gas, that is isothermal, like isothermal expansion of the gas. Here remember that यहाँ पे सिर्फ isothermal है, not isothermally reversible. Let's take the question based on our first formula to find the work done. Here is this question on your screen. Moles of an ideal gas are expanded isothermally. The keyword has come, that is isothermally, from 15 dm cube to 20 dm cube. 15 dm cube is initial volume and 20 dm cube is final volume. If the amount of work done is minus 6 dm cube bar, find the external pressure needed to obtain this work. So here is our question, and in that question we have given that initial volume is 15 dm cube, final volume is 20 dm cube, and our work done is minus 6 dm cube into bar. Here we have given the work done with its sign. हमें हर बार वर्क डन उसके साइन के साथ नहीं दिया जाता, so that we have to find. So whenever there is the expansion of gas, our work done will be negative, and if there is compression of gas, then our work done will be positive. So let's get back to our question, that here we have to find the external pressure. Our formula is minus PEXT into delta V. Delta V is equals to V2 minus V1, that is 20 minus 15, 5 dm cube. Work done is minus 6. We have to find the external pressure, and our change in volume is 5. This minus sign will be cancelled and external pressure will be 6 by 5, that is 1.2 in bar. But if you have seen the options of the question, the answer is given in the quantity Pascal. So we know that 1 bar is equals to 10 raised to 5 Pascal. So our final answer will be 1.2 into 10 raised to 5 Pascal. Let's move toward the second question based on our first formula. A gas is allowed to expand against a constant external pressure. Here the keyword is expansion against the constant pressure. The constant pressure of 2.5 bar from an initial volume of XL to a final volume of 4.5 L. If amount of work done is 5 dm cube bar, what is the value of X? Here we have given the external pressure of 2.5 bar. The initial volume XL and the final volume is 4.5 L. Work done is 5 dm cube into bar. Here the sign of work done is not given. From the question there is the word expansion against the constant pressure. So the word expansion gives the idea that work done is negative. Work done is negative. Our formula is minus PXT into delta V. Work done is minus 5 and our pressure is minus 2.5 and delta V is 4.5 minus X, and here we have to find the value of the X. This sign will get cancelled and 5 by 2.5 is equals to 4.5 minus X. This becomes 2 and our X will be 4.5 minus 2, that is 2.5 L. This is our final answer. So let's take our second formula, that is work done is equals to minus 2.303 into nRT and log of V2 by V1. And in term of pressure, as pressure is inversely proportional to volume by Boyle's law, there will be log of P1 by P2 only. And the term N is equals to number of moles, R is equals to gas constant, that is 8.314 joule per mole per Kelvin. T is temperature and V2 and V1 is our volume. In question, if you are given the isothermally reversible term, then this keyword give the clue that you have to use this formula. Let's take the question, that is an ideal gas expand isothermally and reversibly. The keyword is isothermally and reversibly. These are our volume at 300 Kelvin, that is the temperature, performing 5.187 kilojoule of work. We have given the work done and told to find the number of moles. Temperature 300 Kelvin, work done of 5.187 kilojoule. The work done is given in kilojoule, that we have to convert into the joule. Then it will become 5.187 joule. Here we have to find the number of moles used. Work done is equals to minus 2.303 into N into 8.314 nRT and log of 20 by 10, which is log of 2. We have also given the work done 5187 into N and divided by minus 2.303, 8.314 and 300. And the value of log of 2, as we know, is 0.6931. After the calculation by the log, our number of mole approximately become 3. In this question, you have to focus on the word isothermally reversible. In these types of question, you need to go through the log value. So let's take our last formula to find the work done. and which is the interesting one. W is equals to minus delta NGRT. This is the third formula for finding the work done. Here you have given the reactions. For example, combustion reaction. And the term delta Ng is equals to N2 minus N1. N2 is gaseous mole of product and N1 is gaseous moles of reactant. And R is gas constant and T is temperature. And the clue to use this formula is reaction. Here you need to balance the reaction and then use the formula. So let's take the question. The question on your screen is the work done during combustion of. Here is the name of the reaction, that is the combustion reaction. Combustion of 9 into 10 to the power minus 2 kilogram of ethane at 300 Kelvin. We have given the gas, that is ethane C2H6. And to find the number of moles, we have to first find the number of moles. The given mass of the gas is 9 into 10 to the power minus 2 kilogram. In gram, it will become 90 gram. And molar mass of ethane is 30. So number of mole becomes 90 and 30, that is 3. We have said that the combustion reaction of ethane, that is also the gas, and oxygen is also gas, and with this reactant the product will become CO2 and H2O, and here CO2 is gas and H2O is liquid. Let's balance this equation. In the reactant the carbon is 2, then in product the carbon should be 2 and the hydrogen is 6, then this should be 3 H2O, and number of oxygen in the reactant is 2 and number of oxygen in the product is 4, 3, 7. Then we have to adjust here 7 by 2 O2. And this is our balanced equation from which we can find the work done, and this is for 1 mole only. So our formula is work done is equals to minus delta Ng into R and T. We have to find the work done in the combustion reaction of the ethane, where delta Ng is equals to N2 minus N1. Here I mentioned the state of the reactant and the product for the reason that here N2 is the gaseous moles of the product and N1 is the gaseous moles of the reactant. Means here we only take the gaseous moles of the reactant and the product. Here N2 is 2 and N1 is 7 by 2 plus 1, that is 3.5 plus 1, 4.5. 2 minus 4.5 will become minus 2.5. That is our delta Ng, that is change in gaseous moles. Minus into minus 2.5 into 8.314, and the given temperature is 300. Here remember to add 3, which will denote the number of moles. As in above reaction, the reaction is based on 1 mole of the ethane, and in question we have given 3 moles of the ethane. So by calculation our answer should be in positive sign, that is our work done is positive. After calculation it becomes 1.87 into 10 to the power 4 approximately. Then our final answer becomes 18.71 kilojoule. With this, I will stop here by considering that you have understood all of today's concept. If there are any doubts, then let me know in the comment section. Thank you and all the best for your preparation.